on calculus. Oh wait, did you want more of this? No one. We'll see how good you are today if you get that one.
I'm tired, so I'm pretty good.
Today we're going to talk about a big calculus word. Derivative. You've been finding the derivative when you find the slope of a curve or when you find the slope of the tangent line. We just haven't been calling it a derivative. And so today, instead of having to say, let's do that limit thing, we can say, let's do the derivative. So I copied some words from your book, right? The derivative was a 17th century breakthrough that enabled mathematicians to unlock the secrets of planetary motion and gravitational attraction of objects' position over time. I wrote what you're doing today, defining a derivative, so that you can do calculus. Because without derivatives, there is no calculus. Just so you know. You seem unimpressed, but... Okay. The slope of a curve at a given point is called a derivative. So we can say the derivative, you have to fill the blanks in. I'll print your notes out. I'm going to let you do nothing. The derivative of a function with respect to the variable x is the function, so this is the notation for derivative, f prime of x. You see that?
Somebody else did a Snapchat photo of that. I was like, what is that? I know this photo.
F prime of x, that's what we say, it means derivative. And the definition of a derivative is that limit thing that we've been doing. So now we can say, instead of saying the slope of the curve, or the slope of the tangent line equals, we can say f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Provided the limit exists. So really, a lot of today is knowing the notation, knowing the wording, lots of new vocabulary, but really not really doing much new stuff, except for there is an alternate form of the definition of derivative that I'm going to give you in a minute. Okay? Good? Good, since I printed these out. So if f prime of x exists, we say that f has a derivative, aka it's differentiable. That's a big word, right? Play that word in Scrabble. I don't think you get enough tiles in Scrabble to play. Differentiable. So when it says find the derivative, or find f prime of x, it means find the slope of the curve at that point. So when I say find the derivative of x, oh wait, we're not finished yet, are we? A function that is differentiable at every point in its domain is a differentiable function. Sometimes I think I should make the box a different color than white so that I know that. Okay. I think it's cooler when it's white.
Was it you who figured out you could change the color of
the slide thing? Yeah. I think only Mrs. Hodge and I can. No, because I bet she doesn't use that. She uses that thing? Okay, so when it says find the derivative, it means find the slope of the curve. But they don't give me a point, which means we like to find just the slope of the whole curve, so then we can plug in any point that we want, right? So our answer is going to have x in it when they don't say find the derivative at this value. Yes? So I'm going to say f prime of x equals the limit as h approaches 0 of f of x plus 3, just kidding, x plus h minus f of x all over h. there's no number in this. We're going to keep x in it. So that means I'm going to plug x plus h in for x. So that's going to be f, just kidding. That's going to be x plus h cubed minus x cubed all over h. With me so far? X plus h cubed, is that just x cubed plus h cubed? No. So we could just FOIL it out, like where you do x plus h times x plus h times x plus h. Or, do you remember good old Pascal's triangle way of expanding it? 1, 3, 3, 1, where the x goes down by 1 and the y goes up by 1. Remember that? Kind of, sort of. If you don't remember that, here's the nice thing. X cubed is the biggest number they're going to give you right now, because imagine doing this like the x to the 5th. It just gets kind of annoying. You can always do this, where you have to FOIL these two out and then you distribute. But last year we learned that shortcut, where if this is to the 3rd power, we could do the 4th row of Pascal's triangle, which is 1, 3, 3, 1. So that would be x cubed plus 3x squared h, because that's the other one goes up by 1 as the x goes down by 1, plus 3xh squared plus h cubed. Kind of vaguely familiar with that from last year? And then that kind of saves a little bit more time than FOILing it all out. I don't know why I did that. Minus x cubed. Oh, how nice. No, the derivative did that. So then I can factor an h out, right? So I would get 3x squared plus 3xh plus h squared all over h. And remember, the goal of this is we want to take the limit as h approaches 0. So the goal is get to the point that we can cross those h's out, so we can just do direct substitution. So now we can just plug 0 in, and we can say that the derivative is 3x squared, because that's going to 0 and that's going to 0. Yes? So if you find the derivative just in terms of x, this represents the slope at any point on that curve. So now I could say, what is the slope at 0? And you can plug 0 in and you can say 0. What is the slope at 2? You can plug 2 in there and get 4 times 3 is 12. All right, so this just represents the slope at any point on that curve, aka the derivative of the function. There's a calculus shirt that says, because we call derivative, I don't know. I don't know if we know the joke yet, but friends don't let friends drink and derive for derivative.
Yeah,
That's math joke for you. There's lots of calculus jokes that you get to learn now because you know calculus. There is this thing called the alternate form of the definition of the derivative, and it's if you're taking the derivative at a point, all right? So on your homework today, there are some problems that say use the definition of a derivative. There's some that say use the alternate definition of a derivative. By the time we have a test, I'll let you use either one. You can only use this one if they give you a point. So like on the last one, when they just said find the derivative of x cubed, we couldn't use this because they don't give us a point. But on a question like this, where they say find the derivative at x equals 2, if they give you a point, then you can use this. So why do we like this? Because it's simpler and it's easier. All right, so it says the derivative of a function at a point where x equals a is the limit. So the f prime of a is equal to the limit. Can you read that? Grady, you're not looking. Can you read that? You got to write this down. The limit as x approaches a, right? Notice there's no h in this problem. And A is the value that you're taking the derivative of f of x minus f of a over x minus a. No.
That's not average speed.
Well, it wasn't a limit, right? Average speed, we didn't take the limit. But it's similar. It kind of looks like slope formula, right? Kind of. Which that's what we're doing, right? All right. So let's pretend this is which one of these should be A and which one of these should be X? Do you think it matters? Can you extend your line up a little bit? Just make yours not go past the line. I never thought about this before. Like, I always just take this formula and it makes sense to me. If x is 2, like x equals a, that's my a value, I just plug it in. Matt McKinney, I think it was Matt McKinney. Someone. Sean Logue. It was Sean Logue. You remember Sean Logue? He had a really hard time with this formula because he says if x equals a, then these are always the same, like x and a are always the same, and like really like never got past this example on the day that we did it because he really struggled with this idea. But x is just x, and a is representing the value that you're doing. So I had this picture that goes along with it. So if I called this a, this would be f of a, right? And if I called this x, then this would be f of x. And I just drew all this picture to help because Sean made me realize that maybe people get confused by this formula, and he is the only one that ever wanted to tell me that he was confused by it. That a and x are not the same thing. A is just the point that we're taking the derivative at. It's a really nice explanation in your book. Did you ever think about that until I brought it up?
So we're using that formula this time?
Yeah, we're going to use that formula. We could use, okay, but we could go ahead and figure out what the answer is supposed to be. We just did the derivative on the last one. What was our final answer on example 1? We said f prime of x equals 3x squared, which means we could find the derivative at 2 by plugging 2 in there, and I think that should equal 12. But you had to do all that work with the h's. So I just want to show you why people like this formula. All right, if I want to find f prime of 2, instead of doing the limit as h approaches 0, I can do the limit as x approaches 2. So a is 2, and I can say f of x minus f of 2 all over x minus 2. So I'm just replacing a with the number that I'm finding the derivative of. And this is a lot less algebra than the last one, like a lot less working out. Because what is f of x? F of x is x cubed, right? So we can say x cubed minus, what do I get when I plug 2 in there? 8 all over x minus 2. Oh, x cubed minus 8. Who remembers how to factor difference of cubes? I do these on the notes because it's on the homework, so that way you'll have these formulas for cubes and for expanding stuff. Something like that, right? Let's see. So it's x minus 2, right? So it's like the two numbers that are cubed go in here. So that's a good thing because that x minus 2 is going to cancel. And then you square the first one. So it's x squared. The last number is always square 2, so that's going to be 4. Do you remember what goes in the middle? Just multiply times each other. And I think it's plus, right? Plus 2x plus 4. So maybe you should write this down. Just for point of reference. A cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. And a cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. So minus is always minus first, and plus is always plus, and then the signs change. So it's minus plus plus, plus minus plus. And we again, they're not going to give you anything higher than a cube because it does take a lot of work to do these kind of things. But again, especially if this wasn't a cube, it's a lot easier. But do you see how these x minus 2's are going to cancel out now? So now I can do direct substitution and just plug 2 in there. So I'm going to get 4 plus 4 plus 4, which also gives me 12. So other than today, eventually you can always use the original one. Today I want you to practice with this just because I think that it's worthwhile to do for a day. But when it comes time for the test, if you always want to do the H1, you can. Again, on the AP exam, multiple choice, sometimes they give you questions set up like this, and they want you to recognize that that's the definition of a derivative. So that's why also I think it's worthwhile to spend a day on it, because on the multiple choice stuff, you want to recognize, oh yeah, that means derivative at 2, and eventually you're going to know that it's 12 without doing all this work. Very soon you're going to know the shortcuts. Like, next week. Maybe even Friday, I don't know. Friday's unsure. Haven't planned that far ahead. Mr. Parker used to come and check our lesson plans every Monday, and Mr. Schimpf doesn't come and check our lesson plans every Monday. And so it used to be I had to have my week all planned out, and now I don't. Like now, I don't have my lesson plan book filled out any more than that board up there is filled out.
Well, how am I gonna get there?
Because there's no one checking on me to make sure it would change every week. Like I would scribble and do all this stuff because it would change because life happens. But at least it was filled out. But now I. All right, here we go. All the things that mean take the derivative, or all the ways of saying it. All right. So if a function is differentiable at x, that means the derivative exists at x. So differentiable just means it has a derivative at x. I don't know why I covered this up since you have it written out for me. But differentiable on an open interval means that it must be differentiable at every point in that interval. And we're going to spend a lot of time in this chapter talking about when doesn't a derivative exist, because there are times that it doesn't exist, and that causes us problems. And all of the following are ways of writing the derivative. You're going to see that they use all of them in the book. I'm going to use them all. You hopefully will start using them all. We tend to stick with f prime of x or y prime because those are what we think of the most, but all of these are used, and so you want to make sure that you are aware of it. So f prime of x, I just wrote, I should have left you write these, but I just wrote how you say it, f prime of x. I know I used too many ellipses here. F of x is the same as y, so you can also say y prime. If you don't put the prime there, I don't know it's a derivative, so it's really important that you start putting what you said is equal to. If you're finding a derivative, use one of these notations. Also, we're kind of thinking about this as slope, right? Slope of a curve, so that's where these other ones come from. dy over dx, for slope, we can say like the change in y over the change in x. So when we're talking about the derivative, we can say the derivative of y with respect to x. You have respect x. So when it says dy dx, that means like all of those means you've already taken the derivative. The next one here, this is the notation if they're telling you to take the derivative. So this means like take the derivative of f of x. The derivative of f at x. And honestly, they're getting a little crazy here. This last one is not used very often. I'm not even sure. I think we would say this, I don't even know, the same way, but I wrote this. Not sure. But it means take the derivative, if it makes you feel better. Okay, I should Google it. Okay, ready? Find the value of f prime of 2 for f of x equals 3x minus 7. Do you want to do the H definition or you want to do the alternate definition? We have two ways to do the derivative. We have the h way, we have the alternate way. If we do the alternate way, you have to know this. You have to know that f prime of 2 is the limit as x approaches 2. And what is it? Is it f of x first or f of 2 first? F of x minus f of 2 over x minus 2. Right? That's a nice way. We can do the alternate form because we're finding it at a point. The other way, and I'm just going to write this down here just so you can see this, is if you want to do f prime of 2 using the other way, this would be how you would set it up. The limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Both of those mean the derivative, and both of them should get you the same answer. You just get to kind of pick which one makes the most sense to you, but know that sometimes you're still going to have to go back to the h way, because if they just give you x, you have to do it this way, because you can't have x minus x. That's why. Alright, so I'll do it both ways, just so you can see it. Hopefully you'll see that the alternate form is not so bad on here. You might not rewrite limit every time, but at the end of that problem, before you take the limit, I really want you to say that you're taking the limit. Like, that's how you know that your answer is not the fraction that you get there. So what would this be? 3x minus 7 3 times 2 is 6 minus 1. Oh, sorry, 6 minus 7 is negative 1, but minus is plus 1. Over x minus 2. This is why we spent a whole chapter on limits, because now you have to be able to take the limit of this, right? So you get 3x minus 6 over x minus 2. How can I take the limit of that? Factor out of 3. How would I plug 2 in there? You know where to plug 2 in, right? No, it means 3 is the limit. 3 is the derivative. F prime of 2 equals 3. What do you notice about this problem?
It's a linear line.
What's the slope of that linear line?
I thought it was blue. I was like, why don't we just find a point?
The slope is 3. On a linear line, is the derivative, no matter where you pick, going to be 3? Right? So pay attention to that. If it's linear, you already know the slope. You've been doing the slope of that since you were like 12.
Whoever catch that.
What?
Whoever catch that.
Eventually. Maybe. It's just 3, right? So when there's no x left at the end, right, that means it's always 3. It doesn't matter what number you plug in. Do you want me to do this one too? Just to remind you, you know how to do that if it says 2 plus h minus. You still get 3. I'm going to do it. So you get 3 times 2 plus h minus 7 minus, again, that would be negative 1, so that would be the plus 1 all over h. So you get 6 plus 3h minus 6. It's getting weird, but the 6's canceled out, so then I can cancel h's out. So you still get 3 as your answer. Alright, so you get the same answer. Again, this is linear, so if you notice that, you don't have to do all that work every time. What? No. If I said find the tangent line.
Oh, dang it, tangent line. I was thinking.
Right? Normal line is a reciprocal. Tangent line, we're going to use the slope we got. And remember, for a tangent line, you just need a point and you need a slope. Well, the slope is now the derivative, right? Like, that's the way we can show it. So we know that that is 3. How do I get my point? equals 2, so that means I want to do f of 2 and get the y value that goes with it. So for tangent line, you want to plug the point in to get the y, you want to plug the point into your derivative to get your slope. And what do we get when we plug 2 in up there? Negative 1? So we could say y minus negative 1 equals 3 times x minus 2. Watch what happens if you put this in slope-intercept form. Because it's linear. Because it's linear. That's why. Most of them aren't linear. But I just want to kind of make that connection about slope that we already know how to do.
Is there a linear way to homework?
I don't know. I don't remember. Perfect. Notice I'm giving you odd problems because I want you to be able to check your answers. There should be work with these answers, right? So you got to give me more than just answers, especially when I'm giving you all odds or all but one odds. Also, that means on homework quizzes, a lot of times you're going to get odd problems, but again, the work has to go with the problem to get your credit on those. Okay? I don't have a homework sheet yet, but